So hello and welcome everyone to the YouTube channel of Infinity Learn by Sri Chaitanya, and in the series of rotational motion. Today I am going to start the first rolling motion series. Okay, so here from today's lecture we are going to begin pure rolling motion. So today what we are going to do is we are going to understand the kinematics of combined motion. That means what is combined motion first of all, that is rotational plus translation motion, that we will understand. Then we will understand how to figure out the displacement of a particle of a body performing combined motion. It's how to figure out displacement, how to figure out velocity, acceleration, then moment, linear momentum, then angular momentum, and then kinetic energy of the body or the points of the body which is performing combined motion. Okay, so these are the things which we are going to figure out today. Okay, so I am Ravindram and let's begin this lecture. So number one, first of all, let's understand what is combined motion. Okay, so very simple. First of all, what is combined motion? As we have already studied, okay, as we have already studied that combined motion is the combination of pure rotation plus pure translation, or I don't need to write pure word also, I can simply say rotation plus translation. You know what is translation, what is rotation? Okay, see, translation means when the velocity of every particle of the body at any moment is equals to the velocity of center of mass. That means you take any particle in this body, every particle is having same velocity as that of the center of mass. This is what we mean by translatory motion. So that means whatever is the velocity of center of mass, exactly same velocity is of every point of that particular body. And what is pure rotation? Everybody knows. Pure rotation means, suppose this is the body and this is axis of rotation. About this it is rotating, that means what is happening here? Every particle of this particular body is performing a circular motion. If I take this particle, it is also performing a circular motion about this axis. Do you understand? When all the particles are performing pure circular motion about a fixed axis, we can say that the body is having pure rotational motion. Okay, so when we combine these two motion, then what do we get? We get a combined motion. Okay, now what is the meaning of combined motion here? Let's see it here, students. Let's take an object. For example, this is a rod, and this rod, this is the axis of rotation, or we can say this is center of mass also. Now let's say this rod is rotating about center of mass, and at the same time its axis of rotation is also moving forward with certain velocity. Do you understand? That means this rod is rotating as well as its axis of rotation is moving forward with a certain linear velocity. Suppose I say this is pure translation, right? This is pure rotation, right? And this is translation plus rotation, right? So where do we see this example? There are many live examples in front of us. For example, let me take one example. Suppose you see a fan rotating in a railway, in a train compartment, right? So there is a fan which is rotating in a train compartment and you are sitting inside. So with respect to you right now, this fan is performing pure rotation, right? So with respect to you, this fan is performing pure rotation right now. But if this train is moving forward, then what is happening? This axis of rotation is moving forward. So the person who is standing here, for him this fan is performing a combined motion. That means its axis of rotation is also moving forward and it is performing pure rotation about that axis as well. Do you understand? So body is performing pure rotation about the axis, simultaneously that axis is performing pure translatory motion. That means it is moving with certain velocity. I hope you are understanding what I am saying. Simple. Now one more example, it's a very simple example. Sudarshan Chakra of Lord Krishna we all know. So how does the Sudarshan Chakra moves? It performs combined motion. It is rotating about its center of mass as well as its center of mass is also moving with a certain velocity. So the motion of the Sudarshan Chakra of Lord Krishna is also what? A combined motion, right? So now let's understand how do we define the displacement of any particle in a in a translatory, rotational and combined motion. Okay, let's see. Suppose it's a translatory motion. Let me take an example. Suppose this is a ring. Okay, this is a ring, and this ring is just moving forward with a certain velocity v, right. Let me take some point on this ring. Let's take this point A. Suppose this ring moves a distance x here. Okay, how much distance it moves? It moves x distance here in time t. So what is this? You will say, sir, x is equals to Vt, right? X is equals to Vt. So you will say, sir, point A will reach here. If this is performing pure translatory motion, number one. If there is pure rotational motion happening, then what will you say? You will say, sir, initially A is here and this body is just rotating with an angular speed omega. So after some time t, let's say this point reaches this point, okay, A reaches here. So at t equals to 0, point A is here, and at any time t, point A is here. So what is the angular displacement? You will say, sir, this is the angular displacement. And what is the linear displacement? That also you can measure. Are you understanding? Yes. So what is theta angular displacement? You will say, sir, omega into t, this is the angular displacement. So if it is performing pure rotation, the linear displacement is x, that is Vt, and if it is performing pure rotational motion, then that angular displacement is theta, which is omega t, right. Now let's combine both of them and see what happens if the motion is a combined motion, right. That means if I take a body here and I say that it is rotating, sorry, it is moving forward with v as well as it is rotating with an angular speed omega, then what will happen if I talk about this point A? So what's going to happen after some time, this particle, sorry, the center of mass is moving in a straight line, so no problem, center of mass, if it is here, it will be here now. Okay, so it has performed linear motion, no doubt about it. Let's say this is x, or I should say delta x of center of mass, right. This is delta x of center of mass. Now point A, if I consider pure rotation, suppose at t time A is here, that means it has rotated this much as well. Do you understand? Which is omega t. That means what is the displacement of point A with respect to the center of mass? You will say, with respect to center of mass, sir, point A was here and now it is here. But with respect to a person on the ground, if a person is standing on the ground and watching point A is not reaching here, point A has actually reached this point. So technically this is the displacement of point A with respect to ground. Do you understand this? Are you getting clear or not? Come on, tell me. So you will technically say here, sir, it is very simple. This is the displacement of center of mass. This is the displacement of A with respect to center of mass. And sir, this is the displacement of A with respect to ground, or simply I can say displacement of A actually. So can we see that this is a triangle law formation, and we add these two vectors, we will get this vector. That means overall displacement of A is displacement of center of mass plus displacement of A with respect to center of mass. Okay, one more thing. If I am saying simply displacement of A, it means displacement of A with respect to ground, but if it is with respect to ground, we do not write it there, right. And displacement of center of mass means displacement of center of mass with respect to ground frame. Again, we are not mentioning it there. Okay. Sometimes it creates a lot of confusion. To avoid that, I simply write delta x A means displacement of A. I am not writing with respect to ground, but it means that it is with respect to ground. Do you understand? So delta x of A with respect to ground is delta x of center of mass with respect to ground plus delta x of A with respect to center of mass. That means displacement of A from ground, it will be displacement of center of mass plus displacement of A with respect to center of mass. Are you understanding this thing? Okay. So this is what is actually happening here. So let me take an example. Let's say this is point A, right. This is point A. Now let us say t equals to pi by omega. Okay, this is the time, pi by omega. Now this is moving with velocity v and it is rotating with an angular speed omega, right. The radius you can say r, radius you can say r. So after this time, what is the displacement of point A, right. So what they are asking is find the displacement of point A after this much of time, clear. So this body is performing combined motion, yes or no, tell me. This body is performing combined motion, that means the translation of center of mass and other particles is happening together with pure rotation with respect to center of mass, right. So this body is performing pure rotation with respect to center of mass and the center of mass axis is itself moving with certain velocity, that means it is a combined motion here, right. Okay, okay. So what we will say, let us redraw it somewhere here. Now you tell me after some time what is the linear displacement of center of mass. You will say displacement of center of mass will be velocity of center of mass into time t, and it is a straight line displacement, right. So how much will this be? Velocity of center of mass is v into t. Do you understand? So it is v into pi by omega. How much this? V into pi by omega. Fine, fine. Okay, this is one thing. Now second thing is, what is the displacement of point A with respect to center of mass? Now you will say, sir, with respect to center of mass, A is performing pure rotation, right. That means if it is performing pure rotation, so first of all we need to find out angular displacement of A with respect to center of mass. What is angular displacement of A with respect to center of mass? You will say it is omega into t. What is omega? Omega itself. What is t? Pi by omega. That means it is displaced by pi. Do you understand? It is displaced by an angle. Angular displacement is pi here. So this point A has reached this position. That means its angular displacement of A with respect to center of mass is this. So what is the linear displacement? You will say it is this vector. Can you see that? So you will say finally the point A has reached here. So you will say this is the displacement of center of mass. This vector is displacement of A with respect to center of mass, and this is final displacement of A. Do you understand? So you can simply say, since they are perpendicular, so in this particular question you can say that, sir, this is r plus r2r. Okay. So simply you will say displacement of A vector wise, it will be, how much it is? Pi v by omega times I cap plus 2r times minus j cap. Do you understand? And if there is any relationship given between v and omega, you can put it there and get the final answer. Otherwise this is your answer, and if you want to find out in magnitude, obviously you can find out the magnitude of this vector, which is pi v by omega whole square plus 2r whole square under root. Got it? So this is how we find out the displacement of any particle in a body performing combined motion. I hope I'm clear here. Now let's understand velocity. Okay. So simple concept, if I say position of displacement of A is equals to displacement of center of mass plus displacement of A with respect to center of mass, and if I differentiate, so what will I get? Velocity of A after differentiation is equals to velocity of center of mass plus velocity of A with respect to center of mass. I hope it is clear. Simple formula. If you differentiate both sides, you will get this. So just like displacement, we are getting velocity also. So what is velocity of particle A with respect to ground? You will say it is the vector sum of velocity of center of mass and velocity of A with respect to center of mass. Okay. Let me take an example, you will understand that way better. Okay. Suppose this is an object again, okay, and it is moving further forward with the velocity v, right. At the same time it is also rotating with an angular speed omega. Radius is r. So, there are certain points A, B, C and D. Let us take some easy points, that is A, B, C and D, and we need to figure out what are their velocities. Okay. Now, let us try to understand. We need to find out velocity of, so this is a simple, let us take a question itself. Find velocity of A, velocity of B, velocity of C and velocity of D. Okay. All the 4 points we will take. So, let us talk about first point A. Okay. First is, let us discuss about point A. Okay, I will try once more. Fantastic, now this time I got it. So, this is point A, right, and see what is velocity of center of mass, you will say sir v. Okay. So, velocity of center of mass vector v is already here, plus now if you sit on center of mass and watch point A, then what will you say? You will say sir, with respect to the center of mass, point A is performing pure rotation, and if a body is purely rotating with omega, what is the velocity of A with respect to center of mass? You will say sir, it is r omega in this direction only. Are you understanding? It will be r omega in the same direction. So, what is velocity of point A? You will say sir, it is velocity of center of mass plus velocity of A with respect to center of mass, and both are in same direction. So, I can say I cap. Do you understand? Yes. So, A is moving with a greater speed. A is moving with a greater speed. Now, let us talk about point B. So, here look carefully. Here it is moving forward with velocity v, and with respect to center of mass, if you see, it is going down with this velocity r omega. So, what is this? This is velocity of center of mass. What is this? Velocity of B with respect to center of mass. So, the vector sum. So, what is velocity of B? You will say sir, it is v I cap plus r omega times minus j cap, or you can say v B will be this. Do you understand? Now, same thing will happen with C as well. It is moving forward with v and going up with r omega. So, if you talk about C, you can say like this, Vc vector will be v I cap plus r omega j cap, sorry not C, I am so sorry, not C but D. Okay, like this. So, if you want to know what is the velocity of point B, it will be in this direction, point D it will be in this direction, but let us talk about C. What happens to C? Point C, it is going forward with V, but with respect to center of mass, it is going backward with r omega, right. So, you will say velocity of C here will be, vectorially it will be v I cap minus, or sorry, plus r omega minus I cap. So, it will be v minus r omega I cap. Can you see? This is how we find out the velocity of the points in a body performing combined motion. Okay. So, what you do? First of all, you write velocity of center of mass plus you have to add vectorially velocity of the point with respect to center of mass, which will be usually r, which will be definitely r omega, and direction you have to decide the tangent. Okay. Is it clear? So let's take a simple question. Suppose they give you a question in which a body is moving with v and rotating with omega such that omega is v upon r. This information is already given to you, and now they want you to find out the velocity of point A when it reaches here. Okay. So point A when it reaches this point. So at t equals to 0 it is here, and after some time it is here, or you can simply say find the velocity of point A, that is all right now. So you have to find VA, okay, magnitude wise. So can you do this? Very simple. Pause the video and try this question. So I am trying it now, okay. So you will say, sir, velocity of A will be definitely velocity of center of mass plus velocity of A with respect to center of mass, right? Simply you will say this. Now let me draw it. You will say, sir, if this has rotated by an angle theta, so definitely this tangent has also been rotated by an angle theta, for sure. So this angle is theta. Now what is the velocity of, so this is r omega, this is what, velocity of A with respect to center of mass, and this is what, v. Do you understand? So I will draw it once again here, and you will say, sir, this is vector v and this is r omega. Now you tell me, it is given in the question omega is v by r, so v is r omega, that means this is also v, and what is this angle? This is pi minus theta. So technically you are adding two vectors of same magnitude at an angle pi minus theta. So do you know the formula? Then we are, when we add two vectors of same magnitude at an angle theta, so what is the formula? Suppose I am adding vector A plus vector B and both have got same magnitude, okay. So A equals to B equal to, let us say it is x. So vector A plus vector B mod, do you remember this in vectors we have studied? It is 2x, sorry, it is 2x cos of theta by 2, theta is the angle between them, right? But in this particular question, what is the angle between them? Pi minus theta, and vectors have got same magnitude. So you will say vector COM, this is what? This is actually vector COM whose magnitude is v, and this is what? This is velocity of A with respect to center of mass whose magnitude is v also. So both vectors are different but have same magnitude. So velocity of center of mass plus velocity of A with respect to center of mass, since they have got both same magnitude, so it will be 2v sine, sorry, 2v 2v cos of pi minus theta by 2. So it will become 2v cos of pi by 2 minus theta by 2. I guess it is 2v sine of theta by 2. Do you understand? So this is also one question which can come in examination, which has already come in one exam, okay. So it's like just previous year question only that I am discussing right now, and it's a very common question, okay students. So I hope you must have understood how to figure out the velocity of the point in a body which is performing combined motion, right? Perfect, perfect, perfect. So let's move ahead and understand what is the acceleration of a body performing combined motion. Okay, now let's understand the acceleration of the body performing what? Combined motion. Let's understand again, same concept. You will say acceleration of A will be acceleration of A with respect to center of mass plus acceleration of center of mass, okay. So, here there are little differences. Now, try to understand. Suppose this body is performing combined motion. Suppose it is rotating with alpha and moving forward with this acceleration, right. Now, what is happening in this question? Suppose let us take point A itself, let us take point A. So, what are the possible accelerations of point A? You will say, sir, one it will have, that means acceleration of A will be, first you will add this vector acceleration of center of mass, okay, acceleration of center of mass, plus you will add acceleration of A with respect to center of mass. Now, listen to me very carefully, that what is the acceleration of A with respect to center of mass? See, with respect to with respect to center of mass, A is performing circular motion, and when an object is performing circular motion, there are two possible accelerations. One is tangential acceleration, other one is what? Centripetal acceleration. That means at this moment, if it is having some alpha, then definitely there will be one acceleration, that is A tangential, and another one will be A radial, or I will call it A centripetal, right. So, you will say acceleration of center of mass plus tangential acceleration with respect to center of mass plus radial or centripetal acceleration with respect to center of mass. So, you have to be very careful in order to figure out the value of acceleration for a point on a body performing combined motion. Do you get it? So, here what is happening? It is technically 1, 2 and 3. These are the three accelerations which are acting. First of all, acceleration of center of mass, then acceleration of that is tangential acceleration with respect to center of mass, then centripetal or radial acceleration with respect to center of mass. Are you understanding? So, this is how we figure out the acceleration of a point on a body performing combined motion. Okay? Got it, everyone? Now, it will depend upon the question. So, they will give you a question, the data will be given properly, and accordingly you can figure out the answer. Do you understand this? Yes or no? Clear, 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 clear. Okay, fantastic. Now, let us try to figure out the linear momentum. Now, this is interesting. What is linear momentum of a body performing combined motion? You will say, sir, this is velocity of center of mass, right, and this is velocity, so this is angular speed of the body, right. Now, obviously every particle, you can assume any particle here, m1, like infinite point masses m2, m3, m4 and so on. This body is completely made up of all these infinite point masses. Now, every point mass will have its own velocity, right. So, you will say what is V1? You will say, sir, velocity V1 will be velocity of center of mass plus velocity of 1 with respect to center of mass. Do you understand? Similarly, V2, V3, V4, V5 and up till whatever point masses are there, right. So, what we will do? We will say what is momentum of point mass 1. So, it is m1 v1, similarly p2 m2 v2 and so on, right. So, what is the overall momentum of this complete body? You will say, sir, overall momentum will be p1 plus p2 plus like this. Okay, if I have taken infinite masses, I can write it like this. Okay. Now, what is a p1? m1 v1 plus m2 v2. All these velocities are with respect to ground, right. Now, I will say that momentum is m1 into velocity of center of mass plus velocity of 1 with respect to center of mass. Similarly, m2 into velocity of center of mass plus velocity of particle 2 with respect to point mass 2 with respect to center of mass and so on. Can you see that m1 VCOM, m2 VCOM, m3 VCOM, we can take it out and we will say that VCOM will become common and it is m1 plus m2 plus m3 and so on, right. Plus I will say m1 v1 with respect to center of mass plus m2 v2 with respect to center of mass and so on. Okay. So, this portion is what? Total mass into velocity of center of mass. It is total mass into velocity of center of mass. This is very interesting, that is why I am deriving it, because if I give you directly the formula you won't be able to understand, but I am writing it, I am deriving it so that you can understand the final formula. Now, what about this? Do you have any idea? What about this, students? Now, this is a very interesting thing. Velocity, if you remember that if there is no external force, right, if there is no external force, the center of mass velocity will remain constant, right, okay, or if you sit on center of mass and observe everything. So, we are sitting on center of mass and observing everything, okay. So, what we are getting is this, let us do one thing, let me write like this, m1 v1 with respect to center of mass plus m2 v2 with respect to center of mass. If I divide it by total mass and multiply by total mass, now what will I get? You tell me. If you remember, what is velocity of center of mass? It is m1 v1 plus m2 v2 upon m1 plus m2, like this, yes or no? So, here also we are doing the same thing, just the difference is this is with respect to center of mass, right. So, I can say that vector p is m times VCOM plus m times, now what is this thing? This is velocity of center of mass, but we are calculating this velocity with respect to center of mass only. So, what is the velocity of center of mass with respect to center of mass? It will be 0. What is your velocity with respect to yourself? You will say, sir, with respect to myself, I am not moving anywhere, right. So, your velocity will definitely be 0. So, this thing will become 0. Do you understand? This thing will become 0, and finally, you can say the linear momentum of a body performing combined motion is this. You will say, sir, what is happening when if the particles are rotating? What about that? They are having angular momentum, but not linear. Do you understand this thing? Okay. Now, next one is angular momentum about certain axis. Acha, one more thing I want to add. Suppose they might give you like this. This is a body moving with 2 meter per second and rotating with 5 radians per second. Okay, mass m, radius r, same. And this is moving with 2 meter per second and rotating with 3 radians per second. Okay, same mass, same radius. So, which body will have greater linear momentum? You will say, sir, both bodies will have same linear momentum. If mass is same, then you can say m times 2, that is all. Let us take m is 1 kg, suppose it is 1 kg. So, you will say, sir, p will be 1 into 2, 1 into 2. Do you understand? So, both bodies are having same linear momentum, but yet, yes, there is no doubt they are having different angular momentums. Okay, that we will figure out now. So, let us talk about angular momentum. Now, what about angular momentum? Suppose this is a body moving with velocity v and rotating like this. This is the axis of rotation, sorry, this is the center of mass, and I want to find out the the angular momentum about this particular axis. Do you understand? This is vector r. So, what will you do? Here remember that, see here what are happening, two motions are happening separately, that means pure translation is happening and rotation is also happening about this particular axis. So, first we will write down the angular momentum considering this whole body to be translating. Okay, if this body is translating, its center of mass is here, it is moving with velocity v. So you will say angular momentum because of translation of this body, you will say it is m times vector r cross vector vcom. Do you understand? And what is the angular momentum because of rotation of the body? You will say, sir, it is I about this particular axis. No, 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 that is where you get confused. Because pure rotation is not happening about this axis, pure rotation is happening about this axis. So you will say I about center of mass times omega. Do you understand? Because many times we get confused while finding out the angular momentum. We say that we write this and then we say I should be about this axis. That is wrong. No. See, rotation is happening about this axis. Now, pure rotation is happening about this axis, and this is the formula which is used for angular momentum of bodies performing pure rotation. So, that is why we have to consider I to be the I about moment of inertia about center of mass and not about this axis. Do you understand? So, finally, you will say angular momentum will be m times vector r cross vector vcom plus I about com times omega. Is it okay? So, this is how you will find out the angular momentum of a body about a certain axis, and this body is performing combined motion. Do you get this? Is there any doubt? And we have to be very careful that we are adding them vectorially, right? Sometimes they might have same sign, sometimes they might have opposite signs, okay? So, we will be doing these questions, don't worry, I will be picking up these questions in the YouTube videos only, and we will be doing them. So, after this, the last is kinetic energy. So, same thing, kinetic energy also, we will say the body is performing translation and rotation. So, first of all, what is kinetic energy due to translation? You will say, okay. So, due to translation, the kinetic energy is half m vcom whole square, okay, half into mass, total mass of the body into velocity of center of mass whole square, and due to rotation it is half I com omega square, okay. Do you understand this thing? So, if they ask you what is the total kinetic energy, you will say, sir, it is half mvcom whole square, that is due to translation, plus half I omega square. Do you get this? Is it easy? Let us do a question. Simple question. They are saying that this is a disc, okay, it is left from here, so it was at rest, and this height is h, and when this disc reaches the ground, it is said that it is moving with velocity v and rotating with angular velocity omega, such that omega is v by r. Do you understand? So, they are asking you find v, okay, find v when it reaches the bottommost point. So, this is the question. So, what will you do? Okay. Now, it is mentioned that this condition is prevailing throughout this motion, okay. This condition is prevailing throughout this motion. That means, when it is coming down here, every time its velocity, angular velocity is linear velocity of center of mass upon radius. Every time this condition is maintained. I will tell you why I am saying this. This condition will be maintained, okay. There is a reason behind it. Now, so let's keep it very simple. So, when we will understand about the forces on a body performing combined motion, then I will tell you why I have taken this special case only, okay. Anyways, so let us do it, and why I am saying that this condition should be maintained throughout this motion, why it is like that. There is a reason behind it, okay. So, I will tell you later in the coming lectures, but for now just understand that this is happening, okay. But we have to find out the kinetic energy here, sorry, velocity here. What we will do? Very simple logic. You will say, sir, here there is no external force, like what we will say that here, sir, we can conserve mechanical energy. Okay. So, if we can conserve mechanical energy, so I can say that here the sum of potential and kinetic energy must be equal to the sum of potential and kinetic energy at the bottommost point, yes or no? Yes. So, I will say that mgh is potential energy plus 0 is equals to 0 potential energy plus half mvcom square plus half ICOM omega square. Okay. So, we can say mgh is equals to half mv square plus half I is what? mr square by 2 into omega is what? V by r whole square. Do you get this? So, what will you say? Sir, mgh is equals to half mv square plus mv square by 4. Now, m got cancelled. So, it will be 3v square by 4 is equals to gh. So, 4gh by 3 under root will be the velocity when this disc reaches the bottommost point. Do you understand, students? So, this lecture was basically some information based only. So, I told you how to figure out what is combined motion, how to find out the displacement of a point in combined motion, its velocity, its acceleration, its linear momentum, angular momentum and kinetic energy. So, these things we have covered in this lecture. In the coming lecture, we will start understanding little bit of rolling motion, okay, and then we will start involving the forces acting on a body performing combined motion, okay. So, that is all for today. Thank you, students. Do subscribe to our channel and keep learning infinitely. Thank you so much. Tada, bye bye.